Good morning, class. Today what we're going to be looking at is other angle relationships in circles. So what we're going to be looking at are ways that circles can have intersections happen with them. Not circles themselves, but lines on circles. So there's three main ways for lines to intersect with a circle. Either the lines can intersect inside the circle, like the upper left. The lines can intersect outside the circle, like the bottom. Or the lines can intersect on the edge of the circle, like the right top one. Now, in each of these cases, there's a different rule. Let's go over these rules. We're going to first look at the case of where the angle is on the edge of the circle. If I have a tangent and a chord intersect at a point on the circle, then the measure of each angle formed is half the measure of its intercepted arc. Hold on. This sounds very similar to an inscribed angle. An inscribed angle lands on the edge of the circle, and it's half of the intercepted arc. Whoa, no way. This intersection is on the edge of the circle. The angle formed is half the intercepted arc. No way. It is the case. So if I have a picture like this, and I have a tangent here and a chord here. Angle 1 and angle 2 here. If I know either arc measure, let's say this one here is 120 degrees. What's the other big arc measure? Well, if that's 120, the remainder of the circle is 360 minus 120, so this is 240. Now, this theorem says that if a tangent and a chord intersect, which they do, the angle formed is half the intercepted arc. So angle 1 here, its intercepted arc is 120. So measure of angle 1 equals half of 120 degrees. So measure of angle 1 equals 60 degrees. Alright, well, angle 2 there. Its intercepted arc is 240. So it should be, according to that rule, half of it. So measure of angle 2 should be half of 240 degrees because that's the intercepted arc. So measure of angle 2 is 120 degrees. Alright, quick check. A tangent line is a straight line. Any angles that form a straight line have to add up to be 180. This is 120 degrees. This is 60 degrees. Does 120 plus 60 degrees equal 180? Yes! This theorem works. So if it lands on the edge of the circle, strictly half of the arc. If it lands on the edge of the circle, half the arc. That's the rule. So, do these quickly. Find the measure of angle 1, find the measure of arc RST, and find the measure of arc XY. Alright, so the left one here says find the measure of angle 1. I know the arc's 210. So the angle is half of that. 105 degrees. So, measure of angle 1 equals 105 degrees. Half of 210. Measure of arc RST is going to be double the angle. So double 98, well, 2 times 98, carry the 1. I believe we get 196 degrees. And for this one over here, if I'm looking for the measure of arc XY, well, again, I'm looking for the arc, and I know the angle is right there. So double the angle, 2 times 80 is 160. Boom. So, if it's like an inscribed angle, and it intersects on the edge of the circle, the angle is half the arc. That's the new thing with on the edge. Good? Good. The next thing we're going to look at are angles that intersect on the inside of the circle. So, if I have two chords, or for that matter, two secants, and they intersect on the inside of a circle, then the measure of each angle is half the sum of the measure of the arcs intersected by the angle on its vertical. What? Basically, I'm not going to just use one angle here. And I'm not just going to use one arc. Because that would be misrepresenting something. Because if I had the circles where the lines intersect real close to an edge, I might get a really small or pretty much 0 degree arc. Whereas the other arc would be maybe 100 degrees. So we take an average. What do I mean by that? If I have a circle, and I have two segments or lines that intersect on the inside, That doesn't look like the center. It's not meant to be. This arc is supposed to look bigger than that one. In fact, this one has 40 degrees. This one is 50 degrees. And I want to know, just by happenstance, what x is. Well, I might be tempted to say, well, that's 40 degrees. Well, and then I'd be tempted to say, well, y over here should be 50 degrees. But then we say, whoa, hold up. If x is 40 and y is 50, and those two are vertical angles, x and y are vertical angles, how can I call this one 40? How can I call that one 50? Because vertical angles have to have the same measure. So we made a compromise. We said, well, we're not going to use one, and we're not going to use the other. We're going to use both. And we're going to take the average of them, which means I'm going to add up, for instance. If I want to know what x is, that's going to be the two added together. 50 plus 40. But I'm not leaving it at that. I'm not going to say x is 90 degrees. No way. It's half of 50 plus 40. So 50 plus 40 is 90. Half of that is 45. That's what we're doing here. On the inside, we don't just choose one or the other. We choose both for the vertical angles. We add them together. We take half of it. So let's do a few examples. Find the value of z. So there's two circles. Try and find them on your own quickly. See if yours answers match up to mine. Alright, so for the last one, if you did this correctly, let's just see real quickly here. I believe you end up getting 115 for z. And for the right one here, I believe you end up getting 45 for z. So 115 and 45. But let's make sure we did it correctly. Now, z here, I'm not just going to choose 145 for my answer. I'm not just going to choose 85. It's going to be the average of the two because these two are vertical angles. So I'm going to use those two arcs as an average. So z equals half of the two added together, 145 plus 85. Well, z equals half of 230. Half of 230 is 215. Yes. And why did I say 215? 115. Whoopsie. Alright, this one here. I want to find z. I might be tempted to say, wait, I'm going to add those two together. 125 plus z times by a half. But what does that equal? Does it equal 95? No, it can't. Because 95 isn't the right matchup. It's the vertical, or the top and bottom, instead of the right and left ones. It doesn't match up to z 125. It matches up to this bottom arc and that top arc. So I need to first of all find what that measure is there. Well, this is a straight line. A straight line is always 180 degrees. So 95 plus what equals 180? Or 180 minus 95, I get this to be 85 degrees. This is 85 degrees. So when I add 125 and z together, and I divide by 2 or multiply by half, that value will always equal that interior angle, 85 degrees. Solve for z. Z is all the way over there. So I want to do the furthest thing from z first, so I get it by itself. For this is a half, so multiply both sides by 2. So this side becomes 170, and this is 125 plus z. Well, z is almost by itself. All I have to do is subtract 125 from both sides. So z equals 45 degrees. Although I think z already has a degree symbol, so I'm just going to leave it as z equals 45. And there I go. That's how I will do problems like this. I will add the arcs together, divide by 2, and set it equal to that interior angle. The arcs I choose will be arcs that are across from each other and will be across from the vertical angles that they're using. It does not make sense to use 95 here because its arcs don't match up. They're not across. They're kind of like kitty corner or something. Alright, So we've looked at angles on the inside. We've looked at angles on the edge. Now it's time to look at angles on the outside. There's 3 different cases, but these 3 cases all boil down to one thing. When I look at them, yeah, it might be a tangent and a tangent, or a secant and a tangent, or a secant and a secant. And again, the question is, which arc do I take? Do I take the arc on the far side or the near side? Or do I take one? Do I average them again? What do I do? Well, if I look here, this arc here is bigger. This arc is smaller. I don't think I could choose one over the other because that wouldn't be a good representation of that angle. This arc here is bigger. This one here is smaller. Again, it doesn't make sense to make that the angle. Same thing here, bigger, smaller. Now, you might say, hey, do I add them together, divide by 2? And that sounds reasonable. That's what we just did. But let's look at this case here. If I take this big arc, and I take this small arc, and I add them together, well, that's the whole circle, 360 degrees. If I divide that by 2, I get 180. Does this angle out here look like 180 degrees to you? No, it doesn't. So adding them together divided by 2 doesn't work for the outside. It works for the inside, but it fails horribly for the outside. The way we think of this is because it's left out. It's outside of the circle. These angles aren't as positive about their situation. They're a little bit down on themselves and negative. So that's why instead of adding the arcs together, we subtract them and then divide by 2. It also gets us a smaller angle for the outside arcs. So what I do for each of these is I add the arcs that it crosses. So for instance, in this left one here, this arc on the left and this arc right here on the right, I would subtract them from each other, the big arc minus the small arc. I would divide by 2. That would be the measure of that angle right there. For this circle here, this measure of this arc, I would subtract this arc from it. So this arc minus this arc, divide that measurement by 2, and I get this angle right there. This one here, big arc here on the left, minus small arc on the right. Divide that result by 2, I get that measure. And that will be less than 180. In fact, it should be less than 90. So these all work for me. These all give me a measurement that makes sense. So let's apply this in an example. In this one, it says, find the value of each variable. Now look, the angle I'm looking for is on the outside of the circle. So unlike the ones I just did, I won't be adding them together and dividing by 2. I'll be subtracting them and dividing by 2. So if the angle is on the outside of the circle that I'm looking for, when I do this here, it might be a tangent, it might be a secant, but that's not a huge concern to me. So let's look at the left one here. Left one, angle on the outside? Yes, check. So that means I take the big arc that it intersects minus the small arc. Big arc minus small arc. So 114 minus 56. I want half of that value. And that will be equal to my angle right here. So big arc minus small arc divided by 2 is that angle. So y equals 1/2 of course I had to choose one that wasn't too nice to me. It's an 8, of course, 58. Half of 58 ends up being 29. So y is 29. Reasonable. This one over here. Well, I see variables, but that's not going to stop me. 3x minus 2 is my big side, so that's first. 3x minus 2. Now this quantity is going to subtract the smaller arc right there, minus x plus 6. This whole thing I'm going to take half of, and that should equal my angle, which ends up being 34. So I set up normal way. Big arc minus small arc, half of that equals that angle. It just so happens my number is way out there. Let's try and reduce the inside here first. This -1 gets distributed, so this is going to be 3x minus 2 minus x minus 6 on the inside. And 34 equals half of this simplified. And this simplified is going to be 3x minus x, which is 2x, negative 2 minus 6, or negative 8. I could distribute 2 here, or I can multiply both sides by 2. Because 2x and 8 are both even, let's distribute. 34 equals x minus 4. Solve for x, add 4 to both sides, x is 38. And that's all there is to it. The hard part, setting it up correctly. So, if it's on the edge of the circle, it's half the arc. If it's inside the circle, it's half the sum of the arcs. If it's on the outside of the circle, it's half the difference of the arcs. That's all these theorems allow me to do, is it allows me to find the angles I am looking for. And these relationships are how we find them. I want you to try these 3 problems quickly on your own. Alright, if you did this correctly, 4, you should have got y to be 61. 5, you should have got a to be 104. And for 6, if you got it, awesome. You get something real close to 222 if done correctly. Something real close to 222 for x. It's real hard to find. If you got it, awesome. If you didn't, don't worry. I don't think I'm saying anything that challenging to you. But you should have been able to get 4 and 5. 4, you should have got 61 for y. And 5, you should have got 104 for a. That is all I have for you. So for this section, all we were looking at were angles, either on the edge of the circle, inside, or outside the circle. Inside the circle, you add them together, divide by 2. And when I say add them, I mean add the arcs together, divide by 2, and that's the interior angle, inside. If it's on the edge of the circle, you just take the arc, divide it by 2, that's the angle. If it's outside the circle, you don't add them together, you subtract them from each other, divide that answer by 2, and that's the angle. The angle is always positive. And that's all I have for you today. Till next time.